Dear students, today we are going to discuss about a detailed study of stereoisomerism. We are already studied. Stereoisomerism exists in organic molecules due to the difference in spatial arrangement of the atoms. And this stereoisomerism is mainly divided into two types. First one is geometrical isomerism, second one optical isomerism. So today we are looking for geometrical isomerism. First of all, geometrical isomerism in double bonds. When carbon atoms are joined by a double bonds, the free rotation about carbon-carbon double bond is restricted. That is, carbon-carbon double bond free rotation is not possible. It arises when two substituents on each carbon atom are different. We look at in this example, CC double bond. The two valency of this carbon atom are satisfied by two different groups, A, B. Here also the valencies are satisfied by two groups like C and D. On this instance, the rotation is possible like this. That is, for this carbon atom, A replaces B and B replaces A. Here, the C atom replaces by D and D atom replaced by C. That is, when all the four groups around the double bonds are different, like this A, B, C, D, E and Z notations we are using. A detailed study of this E and Z notations we will study later. Now we are looking for geometrical isomerism in rings. Geometrical isomerism is also possible in ring structure like cyclopropane, cyclobutane, cyclohexane, etc. due to the restricted rotation of carbon-carbon bonds in the rings. In ring structure like cyclohexane, due to flipping means rotation of the bonds, cis isomer never transforms into trans isomer and the isomers can be separated. For example, cis-trans isomerism in ring structure. This is the compound cyclopropane. And it is a cis isomer. How it comes cis? You look at this. The CH3, two atoms are situating on the same side. HH. Both are situating in the same side. That's why this isomer is known as cis-1,2-dimethyl cyclopropane. Here, in the case of trans, you look at the change in the position of these CH3 atoms. Both are in opposite side. So that it is known as trans isomer. That is, it is trans-1,2-dimethyl cyclopropane. Look into another example, cyclobutane. You look here. The same way as of cyclopropane, the CH3, the same atoms are situating on the same side of this cyclobutane, HH. That is why it is known as cis-1,2-dimethyl cyclobutane. Here, the same atoms are situating on the opposite side. That's why it is known as trans-1,2-dimethyl cyclobutane. The same way, in the case of cyclohexane, the CH3, the same atoms, group of atoms are situating on the same side of this ring, HH, CH3. That's why it is known as cis-1,3-dimethyl cyclohexane. And this CH3, the same atoms are situating on the opposite side. So it is known as trans-1,3-dimethyl cyclohexane. Then, cis-trans isomerism in double bonds. You look at this. Here, C1, C2, two carbon atoms are there. Above that carbon atoms, BB, same groups. AA, same groups. That are situating on the same side. BB, AA, same side. So that it is known as cis form. Then you look in the transform. Here, carbon atom C1, C2. The same atoms A, B, B, both are situating in opposite direction. That's why it is known as transform. So look at the example. It is known as cis-2-butane. That is, we know that CH3, CH double bond CH, CH3. That is butane. So this CH3 groups, HH, both are situating on the same side. That is known as it is cis-2-butane. Then we are looking for E and Z nomenclature of geometrical isomers. The cis-trans nomenclature cannot be applied if all the four groups around the double bonded carbon atoms are different. Here, E and Z notation is used to assign geometrical isomerism. There is a rule for assigning E and Z notation. That is, if first priority groups are on the same side, the notation Z is given, and if first priority groups are on opposite side, the notation E is given. What is meant by this first priority groups means that we are numbering the substituents around the carbon atoms on the priority order like 1, 2 based upon its molecular weight. That is, higher molecular weight groups we will assign first priority, that is 1. Then next one 2. On like that way, you look at this example. Carbon-carbon double bond. For this carbon atom, the two substituents are hydrogen and C6H5 group. You know that C6H5 have higher molecular weight than hydrogen. So we are giving priority number 1 to this, and second priority is hydrogen. On the same way, this carbon atom, the two substituents are COOH and CH3. We know that COOH have higher priority due to the higher molecular weight. So, priority number 1 is given to COOH and priority number 2 is given on CH3. Then you look at into the example 1. Priority number 1 is here, priority number 1 is here. Priority number 2 is here, priority number 2 is here. Both are situating in opposite direction. That's why it is assigned as E. You look at into Z1, Z. That means the priority groups may be situating on the same side. You look at here CZ double bond. For this carbon atom, one substituent is bromine, another one is NH2. We know that bromine have higher molecular weight than NH2. So we are giving first priority to bromine, second to NH2. Here chlorine and CH2OH. Higher molecular weight is for chlorine. So first priority is given to chlorine and second one is given to CH2OH. So you look at 1, 1. First priority groups are situating on the same side of the CC double bond. 2, 2. So we are giving Z notation to this. So on this way we are assigning E and Z on geometrical isomers. Look into another example also. Here CC double bond. For this carbon atom, the substituents are CHO and NH2. Then CH3 and C2H5. First priority is given to NH2. Second priority is given to CHO. On the same way, first priority is given to C2H5 and then second priority is given to CH3. So, first priority 1, here the first priority given 1, here for this carbon atom first priority is given to here C2H5. 1, 1, 2, 2. Both are situating on the same side, so it is given, it is assigned as Z. Then, here also carbon-carbon double bond HCH3. Here CH3 is given first priority, H is given second priority. Here C6H5 is given to first priority and C2H5 given to second priority. 1, priority number 1 here, priority number 1 here, both are situating on the same side, and priority number 2 here, 2 here, both are in the same side. That's why here the notation Z is given. On this way, we are determine the nomenclature of geometrical isomers as E and Z. Thank you.